Hello everyone, this is Oshani from Cheenta.com. So one of the things about Mathematical Olympiads is ingenuity. So you want to solve problems which cannot be necessarily solved using some fancy formula. But if you think enough about them, then you can look at the solution. And it's almost magical. So today we will be looking at one such problem. It uses something called an invariant or invariance principle. I'll say a little bit more about that in a moment. This problem was discussed in the Junior Math Olympiad program in Cheenta. If you are interested in Mathematical Olympiads, check the link in the description. There are many beautiful courses on that, and we have been doing this for quite some time. We love mathematical sciences. I think you will love this community as well. Alright, so let's go ahead and talk about this problem. So this problem says that the numbers 1, 2, 3, 4 up to 20 is written on the board. 1, 2, 3, 4 up to 20 is written on the board, and there are two players, player A and player B. They're playing a game. So what they do is, player A puts in a sign between two digits. Maybe the player A puts the plus sign between 3 and 4. So player A puts the plus sign between 3 and 4. Then player B will go ahead and put some sign between some two other numbers. Maybe between 19 and 20, player B puts a negative sign. So it really depends on how they play the game and what strategies they have. At each step, every player puts a sign between two digits or two numbers. So each step, a player puts a sign between two numbers. So the sign could be plus or it could be minus, right? Okay, so just to clarify, if there is already a sign between two numbers, of course they're not going to put any sign, and they're not putting signs in the beginning or at the end. They're just putting signs between two numbers at every turn. Player A is the first one to start the game. Player B is the second one to take the turn. Okay, and they keep on playing. And if at the end of this process, we have to perform the operations. Which means that whatever signs you have put, maybe this is minus, this is plus, whatever signs have been put, just perform the operations and compute whatever the final value is. If the final value is even, then player A wins, and if the final value is odd, then player B will win. Okay, so the question is, who will win the game? And this discussion was actually quite fun in the class. Many students were trying out different things, and I'll tell you a little bit about a problem solving strategy that I sort of said in the class as well, that one way to do this type of problems is to experiment with smaller cases. So experiment with smaller cases. So maybe what you can do, that you can You can experiment with maybe 8 or 6 or 4 numbers. If you experiment with 4 numbers, that is 1, 2, 3, 4, and try to see what happens. And one of the students actually did just that. She experimented with 4 numbers, 1, 2, 3, and 4, and she tried out different combinations. And she tried to figure out if there is a pattern. So, step 1, experiment with smaller cases, like make your hands dirty. And step 2, try to generalize from that experiment. That's very important. Okay, so I will just give an experiment with this small case. Suppose in the first step everything is plus, then what would happen? Well, the total sum is 4 into 5 by 2, that is 10. So here I have used the sum of first n natural numbers, the formula for sum of first n natural numbers. If you don't know this sum, you can check in our YouTube channel as the Gauss trick. There's a very nice story around this particular problem. Okay, it's the formula for sum of first n natural numbers, and it's n into n plus 1 by 2. There is also a very beautiful geometric interpretation of it. We discuss it often in our junior math Olympiad program. But anyway, let's coming back to this. The total sum is 10. But of course, you don't know that whether it will all be pluses. Maybe someone put a minus sign somewhere. So I'll just show you the first step and you will immediately recognize what's going on. What I'm going to do is, I'm going to flip. Let's copy this and paste it here. What I'm going to do is, I'm going to flip this plus 3 into a minus 3. So maybe instead of a plus sign, someone put a negative sign between 2 and 3. So I just put it minus 3. Okay, so observe what happened to the entire thing. What happened to the entire value? Since I flipped plus 3 to minus 3, the value reduced by 6. That is twice of the number that has been flipped. 3 is flipped to negative 3, so the total value reduced by 6. That is twice the number that we flipped. So the sum or the total value reduced by twice the flipped number. In this case 3. You see what I'm saying, right? Okay, so initially the total sum was 10. Now the value got reduced by minus 2f. Let's say f is the flipped number, in this case 3, but I'm just trying to generalize a little bit. So I reduce it by 2f. So it was even in the beginning. I subtracted twice. I reduced it by twice of the flipped number. So the total value is still even. The final value is still even. So see what I'm just doing. Every time I'm flipping a number, the evenness of the total value does not change. That's what's invariant. Something that doesn't change when you change certain other stuff. I've talked about it in many problems in the Mathematical Olympiad programs that we have at Cheenta and in YouTube channel of Cheenta. So maybe you can Google a little bit more in our YouTube channel. Invariance principle means that when in a problem, when a bunch of stuff is changing and you want to figure out what does not change, because that is the key to solving the problem. So a bunch of stuff is changing and you try to figure out what is it that doesn't change. The stuff that doesn't change is the magical key to solve the problem. And that thing that doesn't change is known as the invariance of the problem. In this particular case, the invariance is the evenness of the total value, no matter which plus sign or minus sign you use. So I have shown you for the smaller case of 1, 2, 3, 4, can you use a similar argument for 1, 2, 3, 4 up to 20? If you can, put that in the comment section. And also tell me, instead of 20, if we use some other value, will it always stay even? Or in some cases, it won't stay even? Put it in the comment section. As usual, we will invite the best commenter to our YouTube channel for a presentation. And also there are some awards every month for best commenters. So feel free to comment. Thank you for watching. I'll see you in the next video. Keep on doing great mathematics. Take care and bye.